let us begin and move on with our discussion. Okay, so number 14, the second and the fifth terms of a geometric progression are 16 and 2 respectively. Are 16 and 2 respectively. Determine the common ratio and the first term. Determine the common ratio and the first term. Now this one we are told the second and the fifth terms of a geometric progression are 16 and 2 respectively. Are 16 and 2 respectively. Determine the common ratio and the first term. Okay, so that is the question. But before that, I want us to discuss what is this geometric sequence or geometric progression. Okay, so that we understand the concept first of geometric sequence, and then from there we'll be able to answer the question easily. Okay, so when you're talking about geometric sequence. Okay, this one is a sequence that goes around. This one is a sequence which involves. Okay, now we can proceed with the lesson. Okay, now we can continue with our lesson, geometric sequence. And this, first of all, we need to understand what is geometric sequence. Okay, now this one is arrangement of numbers that goes with multiplication and division. Okay, it is just like a pattern that is formed by either multiplication or division of a certain number. Okay, so for example, I can give an example like we can have a sequence of 2, and then with a sequence that starts with the 2, and then 2 times 2 is going to be 4, 4 times 2 is going to be 8, 8 times 2 we have it at 16, 16 times 2, 32, 32 times 2, 64, and maybe up to 128. Okay? Now this one will say it is a sequence or it is a pattern or it's arrangement of numbers that involves multiplication, because from one number to the other you have to multiply it with a certain constant. Okay? And that number that is being multiplied with, it is constant throughout. Okay, like when we multiply 2 by 2, it's going to be 4. 4, you multiply it by 2, it's going to be 8. 8 multiplied by 2 is going to be 16. 16 multiplied by 2 is going to be 32, and so on. Okay, so that constant number that is being multiplied with is what we refer to it as a common ratio. It's called a common ratio. Okay, and how do we get this common ratio? The common ratio, we obtain it by getting the second number, divide it with the first number. Okay, or you take any number and divide it with the previous one. Okay, if you take, for example, 64, you are going to divide that with 32. Okay, to get the common ratio. And that is going to be, by 32, 1 by 32 is going to be 2. If you take 16, then you divide it with 8. 16 divided by 8 is going to be 2. Okay? Or if you take 4, you divide it with 2. And that is how you calculate the common ratio. Okay? And then, this common ratio, it is always denoted now mathematically with small letter r. Okay? And then there is also another terminology that we use. It is the first term. First term. First term, it is always the first number that starts in that sequence. It is referred as the first term. Okay? So meaning that from the first term we can have the second term, third term, fourth term, and so on. And this first term, it is denoted by small letter a. So in this topic of geometric sequence, normally when you find a small letter a, then you should know that it refers to the first term. And then when you get a small letter r, it means it is referring to common ratio. Okay? And therefore, how do we get a term? How do we calculate for a term in a geometric sequence? It is given with a very simple formula where we say finding any term in geometric sequence, it is the first term multiplied by the common ratio raised to power the number of terms minus 1. Raised to the number of terms minus 1. Okay? So from here we can say, for example, we want to know maybe a certain term, 1, 2, 3, 4, 5. Maybe we want to know the fifth term. The fifth term of this sequence. Already we have it, but let's check how can we calculate for a term. Okay, for example, we don't know what will be the fifth term. Then how do we calculate for that term? Okay, so we'll say the fifth term will be equal to the first term. Our first term is 2. Our first term is 2 multiplied by the common ratio. Multiplied by the common ratio, and our common ratio we have already calculated, it is 2. Okay, multiplied by the common ratio, then raised to power n. N is the term we are looking for. If you are looking for the fifth term, then you replace n with 5. So it means here we are going to have 5 minus 1. Okay, therefore from there we can say 2 multiplied by 2 raised to power 5 minus 1 is the same as 2 raised to power what? 4. Okay, so 2 multiplied by 2 raised to power 4, 2 raised to power 4 it is 16. And then times 2 it is going to give us 32. Okay, so our fifth term, according to the formula, is supposed to be 32. And here, from the sequence, when we calculate the fifth term, first, second, third, fourth, fifth, it is also 32. Okay? We can give another example. 1, 2, 3, 4, 5, 6, 7, 8. Let us calculate the eighth term. Let us calculate the eighth term and see what is going to be. Okay, using the formula. So the eighth term, we say the eighth term is equal to a multiplied by r raised to power 8 minus 1. Okay, we said we have n. N is the number of term you are calculating for. Okay, if it is eighth term, then we are going to replace it with 8. 8 minus 1. Okay, so from there we can say the first term is 2 multiplied by the common ratio. The common ratio here, it is going to be 2. Already we have calculated 16 divided by 8, it is 2. So it is, the common ratio is 2, and then 8 minus 1, this one is going to be 7. So 2 multiplied by 2 raised to power 7. 2 multiplied by 2 raised to power 7. We have 2 raised to power 7 is the same as 128. And 128 times 2, we are going to have 256. We are going to have 256. Okay? Now from our sequence, we know that we are multiplying or we are multiplying a term by 2 to get the other. Like here, 64 times 2 we get 128. That means 128 we have to multiply by 2 so that we get the 8th term. And 128 multiplied by 2, you will get the same result of 250. Okay? So that is now how to find a term in a geometric sequence. Okay? And then just briefly, how to get the sum of the terms in a geometric sequence. I'll have to just highlight that and then we go to the question. Okay? How do we get the sum of the terms in a geometric sequence? So we say we have the first term and then 1 minus r raised to power n all over 1 minus r. Okay? Now this one we can also use it as the first term multiplied by r raised to power n minus 1 all over r minus 1. Okay? Now I will explain the difference of the two. Mostly we use the first formula when the common ratio is less than 1. To avoid working with the negative numbers, then when the ratio is less than 1, we use this one. Okay? So that when you subtract 1 minus the ratio, you'll always get a positive value. Okay? Now, in a case where the ratio is greater than 1, then we start with the ratio minus 1. Okay? So that we'll always get a positive value from there. Okay? So I hope we are communicating. So we're saying A is representing the first term, and then R is the common ratio, and of course 1 is the same number you know. Okay? So how do we get the sum of the terms in a geometric sequence? For example, let us add this. I want you to add all this up to the 8th term, which we say it is 256. So add everything and give me the total. Can you add everything and give me the total? That is addition. You be fast, okay? 510. Is everybody getting that? Okay. Then it's 510. Okay, I can see everybody is getting that. 510. So the sum of all that is 510. Now I want us to use the formula and check if you're going to get the same result. Okay? So our first term is 2. Our common ratio, we know it is also 2. We said 8 divided by 4 or 4 divided by 2. Just take a number and divide with the previous one. Okay? So like 4 divided by 2, we say the common ratio is 4 divided by 2, which is 2. Now 2 is greater than 1. 2 is greater than 1. And therefore we are going to use this formula, which we say if the ratio is greater than 1, we use the second formula for easy calculations. Okay? So therefore we are going to say the first term there, we are looking for the sum of how many terms? 1, 2, 3, 4, 5, 6, 7, 8. So we are looking for the sum of 8 terms. Okay? That is equal to, the first term is 2. The common ratio is also 2. And then raised to power 8 minus 1. And then all over, the common ratio is 2 minus 1. Okay? So can you give me the result of the numerator side? Okay, 2 into bracket 2 raised to power 8 minus 1. What do you get? 2 into bracket 2 raised to power 8 minus 1. The numerator, what do we have? 510. 510. And then 2 minus 1, it is 1. So 510 divided by 1, we're just going to get 510. Just going to get 510. So to get the sum of any sequence, any geometric sequence, we use one of the formulas. If the ratio is less than 1, we use that 1 minus the ratio. If the ratio is greater than 1, then we start with the ratio subtracting 1, okay, on the other side. And that's now briefly what we can talk about geometric sequence. There are always questions you can be asked, either to calculate the term or to calculate the sum of the terms in a geometric sequence. Okay, so let us now finish with this question. I hope now you've mastered all that. You must be making your own notes. Okay. So now we can talk of the question. Now always questions will not be asked directly as the way you think. Okay? They will use the same concept. From your side, you are supposed to master the concept. Not cramming. You master the concept and then you will be able to apply it somewhere. Okay? So one of the application questions can be a question like this. The second and the fifth terms of geometric sequence are 16 and 2. The second and the fifth terms of a geometric sequence. So we are talking about the second and the fifth term. Okay, the second term is 16 and the fifth term is 2, respectively. So the second and the fifth terms of a geometric progression are 16 and 2, respectively. Determine the common ratio and the first term. Determine the common ratio. The question is, determine the common ratio and the first term. Determine the common ratio, so I use R, common ratio, and the first term. Okay? Now the second term, remember the formula. We said when you are calculating for any term, it is the first term and then multiply by a ratio raised to power n. Okay? So the second term here, we are going to say second term is equal to the first term we don't know, the common ratio we also don't know, but that one it is second term it is 2, this one is n minus 1. So it is 2 minus 1. 2 minus 1 is just 1. Okay? So ratio is raised to power 1, or you can even leave it without that. Is equal to the second term is 60. So we can say this the first term multiplied by the ratio raised to power 2 minus 1 is equal to 16. That is representing the second term. And then for the fifth term, it is going to be represented by, now you take the first term, we don't know, multiply by the ratio, and then raised to power 5 minus 1. 5 minus 1, which is 4, is equal to the fifth term. We are told it is 2. The fifth term is 2. Okay. Now from here we can say that we have AR is equal to 16. And then a r raised to power 4 is equal to 2. Now this is equal to that, and that one is also equal to that. Okay? Now that means here, if we take this divided by this, the result will be equal to this divided by that. Okay? Because these ones are equal. Okay? AR raised to power 4 is equal to 2. AR is equal to 16. So if these ones are equal, then the other way around will also be equal. If you take this divided by that, it should be equal to 2 divided by 16. Okay? So we can say AR raised to power 4 divided by AR is equal to 2 divided by 16. Okay? So from there, first term can cancel. R raised to power 4 and R. This one, if you divide, you remain with the R raised to power 3. Is equal to, by 2, 1 by 2, this one is 8. So is equal to 1 over 8. So to remain with R, which is the common ratio, cube root. Cube root. So the common ratio in that case is going to be, the cube root of 1 over 8 is equal to a half. The cube root of 1 over 8 will be equal to a half. Okay? So that is going to be the common ratio. And what about the first term? We can use now any of the two. You substitute for value of R, you will get the value of A. Okay? So if we use that, it's going to be the same as the first term multiplied by the ratio. The ratio is a half. Should be equal to 16. Okay? So this will be the same as a half A is equal to 16. To remain with A, multiply both sides by reciprocal. By 2 over 1 multiplied by 2 over 1. So 2 will cancel. A, which is the first term, will be equal to 16 times 2, which is 32. So the first term is going to be 32, and the common ratio is a half. And the common ratio is a half. So, because of time, I will give much of that work in the assignment, but let me just give you another one question as we are winding up. Okay. So far, is there any question? Any question up to that level? No, okay. Others are not answering. Okay. So the third term is 1 of that geometric sequence, and the sixth term is 1 over 27. Then we're told to find the first 4 terms of the sequence. Now this one, we're going to apply the same concept. The third term is the same as the first term, and then multiply by the common ratio, raised to power 3 minus 1. Raised to power 3 minus 1. So 3 minus 1 is 2. So the third term will be represented by that according to the formula, which is equal to 1. Okay? And then the sixth term, we're told the sixth term is given. The first term is A, multiplied by the common ratio, and then 6 minus 1, which is 5. That is equal to 1 over 27. Okay? So from there now we apply the same concept. This, you take the one with the higher ratio, okay, divide with the other one with the smaller ratio. Okay? that will help you to calculate easily. So this will be a raised r raised to power 5 should be equal, this divided by a r raised to power 2 should be equal to 1 over 27 divided by 1. Divided by 1. Okay, so that and that will cancel, and then r raised to power 5 divided by r raised to power 2. When we cancel that, we're going to remain with r cubed. I hope you remember the laws of the indices. Okay, when you are dividing numbers, the powers with the same base is just the same as we subtract 5 minus 2, which will be 3. Okay, so 1 over 27 divided by 1 is just going to be 1 over 27. So to remain with the r, you get the cube root, you get the cube root. And then r will be equal to the cube root of 127. 1 over 27. It's going to be 1 over what? 3. So the cube root of that is going to be a third. A third. Okay? And therefore now we can calculate for the first term. We can say first term equal to first term multiplied by the common ratio. Common ratio we already got, which is a third, then we square is equal to 1. So this will be the same as a times a third square. A third square is going to be 1 over 9. 1 over 9 times a will be 1 over 9. A is equal to what? 1. So to remain with a times 9 over 1 times 9 over 1. So that will be having a is equal to 9. So the first term is going to be 9 and the common ratio is going to be a third. Okay, so I want us to stop there.